Okay, so this little note video is on what we call a solubility curve. Basically, it's just a way that we can look at some different substances and see how we can change the temperature um, to make more dissolve, more of our solute dissolve. So the first thing is this term solubility. So we want to make sure we know what solubility means. Sorry, my pen. There we go. Solubility is just the ability to dissolve. We've talked about that. Ability to dissolve. Okay, so we've talked about what solubility is. We have a few terms that we need to know. So unsaturated basically just means that, I can dissolve more solute. So this would be like if I put a little bit of sugar in some water and I stirred it up, it all dissolved. I put some more sugar in it, it all dissolved, right? I have an unsaturated solution. I can keep adding my solute and it keeps dissolving. A saturated solution, you can kind of see we have some accumulation down here. That's like, eventually you get so much sugar in your water, it doesn't ever dissolve. It's like if you've ever made sweet tea put sugar in cold tea, sometimes it doesn't dissolve. You can taste that gritty sugar. It's because you have a saturated solution, right? You can't add any more to it. Nothing else will dissolve. A super saturated solution, though, means that I've actually done something to my solution in order to dissolve extra solute, okay? Usually what that means is we've increased the temp of our solvent, okay? That's how we've made a super saturated solution. If you've ever had that rock candy, I know you can buy it at Cracker Barrel, or you can get it all kind of different places, but it's like that. It tastes like pure sugar. It's because it is, but it looks cool, right? It looks like little crystals. So the way that it's made is you actually, if you heat up water, you can actually put a whole bunch of sugar in it, get it to dissolve. And then if you kind of set a stick in it, in that water, once that water starts to cool down, that sugar actually crystallizes, like we can see here, out of that water, and it attaches to the stick or the string. And so eventually, as that water's cooled down, all that extra sugar that you made dissolve because you heated up the water, it kind of crystallizes out, okay? So here's a little blurb here on supersaturated solutions. Okay, so it's similar to concentration, but it's just a little different. But my concentration does increase. This says increase. That's hard to say. Increasing concentration as I go, towards my supersaturated solution. Okay, so the main thing we're going to look at here is here's a solubility curve. Okay, don't get too overwhelmed by all these different words, okay, or all these different compounds, these letters. It's not as difficult as it looks. We're just going to be looking at one line at a time, okay? So basically what this does is it shows how many grams of my solute I can get to dissolve in 100 milliliters of water. Okay, so it'd be like if I had a beaker of 100 milliliters, and then it tells me what temperature I need to increase it to. Okay, how much do I need to heat it up? So if something is on the line, we call it a saturated solution. If we're below the line, it's unsaturated, and if it's above the line, it's supersaturated. Okay, so I'll kind of explain in just a minute what I mean by on, below, or above. But you can fill in, right, in your notes what's on your X and Y axis, just so we can get comfortable looking at the graph. So let's look at some examples, okay, and this will kind of help you see what I mean when I'm talking about on the line or above the line. So number one says, what mass of solute, so that means I'm looking at my y-axis because this is my solute, will dissolve at these temperatures. Okay, so my first one is KNO3. Here it is. So I'm just looking at this line for KNO3. okay? I'm looking at 70 degrees. So what I'm going to do is follow my line up here until I intersect with this KNO3 line. Okay, so how much is that? Well, let's follow it over here, right? Well, it's pretty close to like 129, maybe 130. If you said 130, that's fine. Okay, it's close enough. Okay, so that's saying that if I heat my water up to 70 degrees, I can actually get 130 grams of this potassium nitrate to dissolve in my water. Okay, I'm not going to get any more. If I try to put 140 grams, it's not going to work. Okay, it's not going to dissolve. Let's look at B, NaCl. Okay, so let me erase some of this here just so we're not looking at too much. So NaCl is right here. Okay, and this line's kind of weird. It's like right here. It's almost flat. So at 100 degrees, here we are, 100 degrees. So I'm just going to go up my line, right? So now, how much is that? Well, I'm just going to go straight over. I'm going to stay flat, right? So that means 40 grams. So that means I can put 40 grams of NaCl in water and get it to dissolve as long as my temperature is 100 degrees. Okay, let's look at the next one. Erase all that again. So ammonium chloride, right here. Okay, 90 degrees. 90 degrees. I'm going to follow my line up. It meets right here. Follow my line over. 70 grams. Okay, so I'm just looking at an individual line. I'm just kind of seeing where that line meets. That's all I'm doing. Okay. D kind of asks us this question. We're doing the same thing. And just ask it kind of a different way. So let's look at how it words it. So it says, which of the above three substances is the most soluble at 15 degrees Celsius? Okay, so let me find my substances here again. Okay, let me get them all circled. And I'm looking at 15 degrees, so that's like right here. Okay, it's like this line right here. So most soluble, right? That means I can dissolve the most, right? Most soluble. I can dissolve the most. So which one of these lines is higher up at 15 degrees? So let's look. KNO3 is right here. Ammonium chloride is right here. And NaCl is right here. So NaCl is actually the highest line at 15 degrees. Okay, so what that means is that at 15 degrees, I can actually dissolve more water than any of those other two. Okay. All right, let's look at these. So again, most soluble, 20 degrees. Which one can I dissolve the most at 20 degrees? All right, where's my highest line that intersects with 20 degrees? And that's right here. Okay, so NaNO3 is actually the most soluble. Okay, let's look at 40 degrees, which is the least soluble. Okay, so that's the opposite. Which one can only dissolve the least? Where's my lowest line? Right here. Cesium sulfate. Okay, let's see if you can do this one, right? Least soluble, 10 degrees Celsius. So here's 10 degrees. Least soluble means the lowest, right? That means I can dissolve the smallest amount. This is the smallest line. Potassium chlorate. Okay, so hopefully that kind of helped walk you through. You do have a couple, I think 2 of these on your homework module, okay, to give you just a little bit of practice doing that.